Chapter 14, Kinetics, Exercise 14.73. The tabulated data were collected for the second order reaction. We have the temperatures and the corresponding rate constants, K. The unit for the temperature is in Kelvin. The unit here is actually 1 over molar over second. Part A, use an Arrhenius plot to determine the activation barrier or activation energy for the reaction. Over here we have this data points. I copied and pasted these data points here. We have temperature here. We have rate constant here. This is in molar to the power of -1 and second to the power of -1. We'll use Arrhenius equation. This is Arrhenius equation. And then we take the logarithm of both sides. We can see Ln K is linear with 1 over T. The slope would be negative activation energy over R. Ln A would be the intercept. So what we do is we have temperature. We convert it to 1 Kelvin over temperature. We have the data here. The reciprocal of temperature, and then we have rate constant K, but we need to take the logarithm of K. To avoid taking the logarithm of a unit, I'm taking the logarithm of K times 1 second times 1 molar. And then these values are unitless. And then we can take the logarithm of those unitless values. Now we have this, we'll make a plot by clicking insert and the data. I'll make it a bit more compact. This is not really good. I think I need to format the axis to make it look a little better, but it's not critical. So let's go to the trend line and more options. We'll choose linear here, which is the default. We need the equation. We need R squared just to check if the fitting is good. This fitting is nearly perfect with R squared is equal to 1, and we have the slope, we have the intercept. And by the way, the slope is negative E sub A over R, so we have this equation here, and therefore the activation energy is simply the slope times negative R. And the intercept is 23.437, and the intercept is simply Ln A. Actually, it's Ln A times 1 second times 1 molar, but that's not quite difficult to just to understand. You can't, because you just cannot take the logarithm of a unit. All right, what's the logarithm of 1 second? Second. All right, let's get back to here. We're determining the activation energy with the slope. The slope, I just copy the slope here, negative 2646.8 and times negative R, and we'll get the activation energy. This is in joule per mole because I used the value of R in joule per mole Kelvin, so it's going to be 22 kilojoule per mole. So 22, submit. 22 is a fairly small energy barrier. Determine the frequency factor. It's actually a pre-exponential factor because rigorously A is not proportional to the frequency or collisional frequency. A is proportional to the collisional frequency divided by the concentrations of the reactants that collide with each other. So it's better to just call this the pre-exponential factor for the Arrhenius equation. All right, over here A is how much? It's simply we know Ln A. Ln A is simply the intercept. The intercept is 23.437. So what is A? A is e to the power of Ln A. That's it. Oh, this is a huge number, so I will format this to scientific. Okay, all right, 1.51 times 10 to the power of 10. Right, submit. By the way, you can get the slope and intercept without making the graph. So over here, I'm gonna give you the slope, which is simply, you just need to use a slope equation, which is slope. You need to select y first and then x to get the slope. Alright, you see the slope is right here. It's also shown in the graph. What about the intercept? The intercept over here, I'm gonna copy this. So I need to change this to 4 and 4, and change this to 7 and 7, and change this to intercept. Alright, that's it. That's the intercept. So you don't really need to make a graph to get the slope and the intercept for a linear equation. You can just use the equation equals slope and equals intercept, and you need to select the y value, the vertical values, the comma, and then select the horizontal values. So anyway, this is how we get the activation energy, which is the slope of the graph times negative r, and also the pre-exponential factor, which is e to the power of the intercept. Part B, let's see. Okay, yeah, they also got the y-intercept, and then e to the power of y-intercept.